Chapter 3, Section 1 and 2 begins with what I like to call my airport exams. So I'm returning from a long business trip where Northville Public Schools has sent me to Hawaii for a conference, as they oft want to do. And I am at the airport, and I'm excited to see my family. So here I am. I'm right here. My family is up here. And you can see that regardless of the fact that I have two girls, one of them refuses to wear any sort of dress or skirt. When I'm excited to see my family, I can run at approximately 5 meters per second. Not really true, it's too fast. That's okay. On my left, I have a people mover. On my right, there is a people mover. You could also call this a moving walkway, it doesn't matter. Either way, it's the same. The people mover on my left is moving toward my family at 5 meters per second. The people mover on my right is moving away from my family or toward me at 5 meters per second. I have my choice. I could run on the people mover on my left at 5 meters per second. Or I could run on the people mover on the right at 5 meters per second toward my family. On the idea that I would like to see my family sooner than later, Frederick, what do I choose? Why would I choose the one on the left? How fast am I going to be moving if I choose the one on the left? 10 meters per second or 5 plus 5 meters per second. If I choose to run between the two, I will simply be moving at 5 meters per second. If instead I choose to run on the people mover to my right, which is moving toward me at 5 meters per second, and I run at 5 meters per second away toward my family, Lindsay, how fast will I be moving? 0 meters per second. I will go nowhere. And this is something I definitely recommend you do at some point at the airport. You take some time, and you just walk the wrong way on the people mover. It's fun. People have a tendency to look at you, but it's still fun. So I do suggest it. Now, I bring up this example because it's a relatively simple example. But this is a very basic example having to do with the concept of vector addition. Specifically, what we're going to be doing is called tip-to-tail vector addition. But the reason I start with this example is because you already have in your brains the idea behind vector addition. You already understand it, especially in this simple context. Eventually, I'm going to make it look very different, and it's going to be much more complicated. But I want you to understand that on the basic root level, you understand this stuff. You have it's very intuitive. So please understand it. We need to now define the concept of a vector. In order to understand a vector, we need to also write down the term scalar, because they are two different things, but they are related. A vector is something that has both magnitude and a direction. Please remember, magnitude is simply the amount of, right? If we're talking about displacement, it would just be meters. It would be meters per second. It's the kilometers per hour. It doesn't matter. It's the amount. Scalar has magnitude only. It has no direction. We have already identified and worked with scalars, but we just haven't specifically, already worked with vectors, but we haven't specifically identified what they are. Maxim, give me an example of a vector we've already worked with.
Velocity.
Velocity is a vector we've already worked with. Ben, give me another one.
Acceleration.
Acceleration. Peeper, the other one. People. There's a reason I wrote it in this order. Because we learned them in this order. We learned the one you're forgetting first. Frank, help her out. Displacement. Those are the three we know at this point. There are a whole bunch more. We could, for example, talk about force, or we will. Torque, momentum. There are all sorts of different vectors. There are all sorts of scalars as well. We can talk about, just to put them up here, we can talk about distance, speed, time, volume, density, money. Basically, any number of anything will be a scalar. Basically, if it doesn't make any sense to add a direction to it, then that makes it a scalar. For example, we could say 14 calculators east. Does it make any sense? No. 20 hairs left. Hello? Sorry, for example, because we should say 20 hairs right. That would make no sense. But 20 hairs left, and then, never mind. I'm sorry. Okay. In addition, be aware that you can have negative scalars. For some reason, people have this idea that because you can only have the magnitude that you cannot have a negative. But be aware that you can. For example, I think you all agree that $50 south makes no sense. Right? Okay. But you do agree that everyone can have negative money. In fact, most American households do have negative money, right? It's called debt. So be aware you can have negative scalars.